Rational exponents follow the same exponential laws of real numbers, which we have studied in the previous section. So before we get started with the simplification of rational exponents, let's remember a few things. Number one, law of zero exponent. Law of zero exponent. And this is that anything power 0 is equal to 1. Even a fraction a over b power 0, that will always be equal to 1. Number 1. And number 2, this is called the law of negative exponents. Law of negative exponents. So if x is an integer, if x is an integer which has a negative exponent, say x power minus m, exponent is mostly required to be written as positive. So we can bring down the entire number such as this x, and we can change the sign of exponent. This can be written as plus m. So when the numerator moves to the denominator, the exponent changes its sign. And similarly, if the numerator becomes into as a denominator, it changes the sign again. So if we have just 2 power minus 3 over 3 power 2, here the power is negative. If we don't want any negative power in this expression, we can write 1 over and bring down 2 power minus 3 in the denominator, so that the sign of exponent will change. This will become plus 3 into, we already have 3 power 2. So this is, if you want to write exponent as a positive number, we have freedom to move the denominator to numerator or the numerator to the denominator, and we can change the sign of the exponent. This was the case when base was an integer. If x is a fraction, if x is a rational number, such that x is equal to p over q, then x power minus m, well, we can substitute the value of x, which is p over q power minus m. Now, interesting property that we can switch the numerator to the denominator. Now here we can write q over p and change the sign, minus m to plus m. And this is exactly what we did on the previous line. The denominator, which was q, is now written in the numerator, so its exponent must be plus m, and the numerator, which was p, has gone to denominator and it has changed the sign as well. That's why minus m is now changed to plus m. So if it was somewhere you see that 2 over 3 power minus 4, if we can write 3 over 2 equal to plus 4, or if you know somewhere it's written 1 over 2 power minus 1 by 2, it's perfectly okay to write it as 2 power plus 1 by 2, or this is square root of 2. So these are few things which, if you remember, it will just help to simplify the radical signs. And now let's get started with questions and do a couple of questions so that we can further understand the process of simplification of radical signs. So example, simplify (216) power 2 by 3 into 25 power 1 by 2 divided by 0.04 power 3 by 2. Now let's take a look at the expression, and here 216 power 2 by 3 times 25 power 1 by 2 over 0.04 power 3 by 2, and as a whole this expression has power 1 over 2 because square root, that is, this is the radical form, and now I have written this in the exponential form. And the rule is that whenever you see composite numbers like 216, 25.04, always change the numbers to its prime factors, like convert the number to as a product of its prime factors. Let's take a look at 216. How can we change this into as a product of its prime factors? In order to do prime factorization, we always write on the top some initial prime numbers 2, 3, 5, 7 and so on, and see if the number is a even number. If like 216 is an even number, we can get started with 2, and through a small division, 2 one time is 2 and 1 is smaller than 2, so we put 0 here. 2 8 times is 16. 108 is still even number, so we do small division with 2 again. 2 5 times is 10 and 2 4 times is 8. 54 is still an even number, so 2 time is 4. 1 is carried over, which makes 4 as 14, and 2 7 time is 14. 27 is not an even number, so we cannot divide it with 2 anymore, and we jump to the next, which is 3, and see if 3 will divide 27. Yes, 3 divides. 3 9 time, and 3 3 times, and 3 1 time. So 216, its prime factorization is 2 is multiplying 1 2 3, 2 times 2 times 2, and 3 times 3 times 3. So this is how we can write 216 as product of its prime factors. And if we change this these prime factors to exponent form, this will be 2 power 3 times 3 power 3. Similarly, we can write 25 equal to 5 power 2, and we can write 0.04 is in fact 4 over 100. We know that in order to do this, we directly write 1 just below the decimal and then count the number of digits on to the right of decimal point, which is 2. So we place 2 zeros and take away this sign. We are left with 4 over 100. And if we write it in similar exponential form, that's 2 over 2 over 100 would be, if we do the prime factorization of 100, that would be 100 2 times 50 2 times 25, and this will be 2 power 2 times 5 power 2, because 25 is further 5 times 5, 5 times 1, so 100 is equal to 2 times 2 times 5 times 5, which is equal to 2 times 2 times 5 times 2. So now we have calculated prime factorizations for everything. So we are going to place the values here. For 216 we can place 203 times 3 power 3 and then write the power 2 over 3 time 25. We are going to write 5 power 2 and then power 1 over 2, and then for 0.04 we can write 2 power 2 over 2 power 2 times 5 power 2 and then whole power 3 over 2, and we still have this bigger power, which is 1 over 2. So this is always the first step, that look the numbers in the expression and write each number as product of its prime factors, which is, this process is known as prime factorization. So once all the prime factorization is done, then we can apply the exponent laws. 2 power 3 has another power, that is 2 over 3, then 3 power 3 times 2 over 3, and 5 power 2 times 1 over 2, and here in the denominator we have, this can get cancelled with this, and we have 1 over 5 power 2, then power 3 over 2, and whole raised to power 1 over 2. So now 3 will get cancelled with 3, this 3 will get cancelled with this 3, this 2 will get cancelled with this 2, and we have now 2 power 2 here, 3 power 2 here, and 5 power 1 here, and this 1 over 5 can be written as 1 over 5 power 2 times 3 over 2, and still we have 1 over 2 on the top, and now this 2 will be cancelled with this 2, and we can now apply that power 1 by 2 which is outside. 2 power 2 power 1 over 2, 3 power 2 whole 1 over 2, 5 power 1 over 2, and this 1 over 5 which was, this can flip over and this will become 5 power 3 on the top over 1. And again applying the same thing, and then power 1 over 2 as well. And now this 2 power 2 times 1 over 2, 3 power 2 times 1 over 2, 5 power 1 over 2 into 5 power 3 over 2, and this will become 2 is got cancelled with this cancelled with this, so 2 times 3 times 5 power 1 over 2, and this is 3 by 2, so we can add them, add the powers, 3 over 2, so 1 over 2 plus 3 over 2, the denominator is same, and I add the numerators, 1 plus 3, so this would become 4 over 2 which is equal to 2, so this will be 2 times 3 times 5 power 2, 2 times 3 is 6, and this is 25, so the answer would be 150. So this is how we can simplify a complex expression within radical sign. If we do one more question, probably that will help you further. Example, and this time simplify the expression, and this expression is 2 power 1 over 3 times 27 power 1 over 3 times 60 power 1 over 2 divided by 180 power 1 over 2 times 4 power minus 1 over 3 times 9 power 1 over 4. Like we know already that every number has to be converted into prime factorization, and 2 is already prime, so we don't have a problem writing 2 power 1 over 3. 27, as we know, we did it previously. If we convert 27, that is equal to 3 power 3, so we can write 3 power 3 here, and 60 can be written as 60 to 30 to 15 3 5 5 1, so this is 2 power 2 times 3 times 5 power 1 by 2 over. Similarly, if we change prime factorization of 180, that would be 290 245 315 3 5, and then 5 times 1. So this will be 2, so 180 will be 2 power 2, 3 power 2, and then 5. One over 2, and 4 is 2 power 2 power minus 1 by 3, and 9 is 3 power 2 power 1 over 4. So once all the numbers have been converted into prime factorization, it's also known as linear factorization. So once we do that, now we will see what can cancel in the exponent. 3 power 3 times 1 over 3, that will cancel. 2 power 2 times 1 over 2, 3 power 1 over 2, 5 power 1 over 2. And now in the denominator, 2 power 2 times 1 over 2, 3 power 2 times 1 over 2, 5 power 1 over 2, 2 power minus 2 over 3, and 3 power 2 over 4. So once the exponents have been simplified, we can see that this 3 can cancel with this 3, this 2 will cancel with this 2, and this 2 will cancel with this 2, this 2 will cancel with this 2, and see if anything else we can simplify. We are left behind 2 power 1 over 3, 3 power 1, 2 power 1, 3 power 1 over 2, 5 power 1 over 2, divided by 2 power 1, 3 power 1, 5 power 1 over 2, 2 power minus 2 over 3, 3 power 1 over 2, because 2 by 4 is same as 1 by 2. See what can cancel in the numerator and denominator. This and this can cancel. 3 power 1 and 3 power 1 can cancel. 5 power 1 by 2 and 5 power 1 by 2 can cancel. And now collect all the powers with the same base. Here is 2 power 1 over 3. We have another 2 in the denominator, but if we move it to the numerator, its exponent will become positive and will add. So this would be 2 over 3, and here this 3 power 1 by 2 when cancel with 3 by 1 by 2 as well. So that's it. What we are left with is 2 power 1 by 3 plus the power 2 by 3. So if we add, this will become 2 power 3 by 3, that is 1, because 1 by 3 plus 2 by 3, that is equal to 3 by 3, which is equal to 1. Therefore, we got a complex expression simplified, and the answer we got is 2.